Hello, I'm audible, right? Good evening, one and everyone. A very warm welcome to GT Academy. Today we'll be looking at the introduction session on building performance analysis using Design Builder. So this program is in collaboration with Team Catalyst, which is again supported by Design Builder. So let's look into. I am Yashaswini, from Program Manager from GT Academy. So let's talk about who we are, about the GT Academy itself. So, Green Tree Global has been in sustainable consultancy since the past 13 years, and which has been spread across 6 to 7 countries. So, the academy has been started 2 years back. as an initiative to bridge the gap between educational and industry itself. So these are for the students who wants to upskill based on the requirements that's there in the industry, or for the professional who wants to switch to the sustainability field. And Academy also offers few learning management program, which can be accessed for a year upon signing up to any of the course. And the accreditation with many of the international and national organizations that can be overlooking for the certification courses or any other upskills that's required in the green sustainable consultation field. So what we provide is training modules, either from the GT Academy experts or with the one whom we collaborate. And then we focus on the R&D on the sustainability topics. And also we enhance knowledge based on dissemination. And also we collaborate with faculty who are in this field. And also we focus on creating environmental awareness. So far in the past 2 years, this was our progress where the number of panel discussions were conducted and skill development programs were also conducted, that you can see all the numbers here. And our focus was moved from offline to in-house courses also. So there are a number of sessions that are conducted, which you can see in our GT Academy page. So these are all the trending topics that are available today and which are in need, such as daylight simulations or a crash course on examinations, such as LEAD, GRIHA or IGPC, etc. And there are also courses on soft skills and also courses on HVAC simulation, which is the one which will be a part of Design Builder today. So these are the modules that will be covered in the course that we'll be looking forward. So what is exactly the building energy simulation, and look at the Design Builder and how the simulations can be run, the model geometry itself and Windows edge shading, visualization of the model, and the loads, scheduling, and the construction system, and the simple HVAC system, natural ventilation, cooling load calculations. So the course details are given on the left side of the slide. So this course is priced at 12,000 plus GST, and the duration of the course is 3 weeks, with the sessions conducted on every Thursday and Friday of the week, which we are planning to start from the 3rd May 2022. Few ground rules that we would like to follow. Please keep your speakers on mute and videos also switched off. And if you have any questions, please post it in the chat box, which will be take up in the end during question and answer session. So about the instructor, so this entire session would be taken by PC Thomas, who is a director at Team Catalyst, and he's also fellow IBITSA member, that is International Building Performance Simulation. And he is also an adjunct associate professor in the University of Sydney, who has been teaching for the past 15 years in the area of simulations, building code, and compliances. So without much further ado, over to you, PC Thomas, sir.
Thank you, Yeshu. I'll just turn my video on. So today, welcome everyone. And I must tell you that I'm in Sydney, Australia. It is actually 10 o'clock at night. So good evening to all of you. And I hope you are excited as I am to participate in this session. So what I thought we might do is we'll do a very quick introduction on some of the things we might cover during the course, and then we can have a Q&A session So if there are some additional questions, we can work on that. So let me start by providing a small presentation. I'm going to share my screen. And if people can just let me know whether you can see my screen. It should have the title slide which says Building Performance Simulation
Yes,
for
your
Design.
screen is through.
Okay, thank you. So as you've heard that I have 3 roles in my professional life. I'm a director at Team Catalyst. And you can look us up. So just teamcatalyst.com.au. We work on energy efficiency and thermal comfort in buildings. I teach at the University of Sydney, and we also distribute Design Builder both in India and in Australia. So what I thought we might do is, first of all, I'd like to just acknowledge the opportunity that the GT Academy has given me to share this teaching opportunity with all of you. And I thought we might just go through quickly a couple of case studies so you have an idea of what can be done with Design Builder. And then we'll quickly have a look at Design Builder itself. So building performance simulation, previously it used to be called building energy simulation. Now it's not just energy, there's other things as well. But the reason I like to use it is because I always try to use programs that are in the public domain, which are well tested and well documented. So inside the Design Builder interface, you will find energy simulation engine called Energy Plus. It is very well recognized. You can look it up. It's got its own website. You can download a copy free, but it is extremely text-based. So it's very hard to use by itself. There's another engine called Radiance. Again, originally developed by US DOE. Again, to use it by itself is quite it's quite complicated to do. And that's where Design Builder comes in. Now, a couple of things to remember is that one must know their building physics. You can use the models to test your design, but it's probably not a good idea to try and use the software to do the design. And one of the things I always tell people who participate in these training sessions is that if your model is not correct, then your results are not going to be practical. So that's something to just be aware of. So here's what Design Builder does. It is really a graphic user interface which connects to a series of different kinds of analysis that you're able to perform. So you can use Energy Plus, that will allow you to do the building physics for building fabric. You can work out heating and cooling loads and temperatures and relative humidities, all the comfort parameters that you need. There is a visualization engine which allows you to review what the building looks like, and using Energy Plus, you can work out things like how much solar radiation is incident, what is the internal temperature of each of the surfaces or the external surfaces, what are the impact of shading devices, and so on. And then there are other bits and pieces. You can do many of the certifications around the world. You can extend the Design Builder interface using some of the scripting capabilities of Energy Plus, which have now, you can use Python to do some of that scripting to write your own unique controls or analysis, which may not be available in the basic Energy Plus. There are some genetic algorithms available which can do parametric analysis, sensitivity, uncertainty. These are all advanced topics. We won't be covering them in what the course that we're doing, but hopefully we'll get you started so you can work your way onto those things. Design Builder's got a plugin to one-click LCA, which allows you to do life cycle cost analysis. The Radiance engine allows you to do daylighting calculations. There is a proprietary CFD engine, so you can do a CFD analysis as well. Obviously, depending on the version of Design Builder that you decide to procure. So for this case study, which is going to be in Sydney, I've just plotted an average of all the weather parameters. And from here, you can see how the temperatures vary across the year. Now, what I do need to point out is that Australia is in the southern hemisphere. So our winter is India's summer. So, May, June, July, August is low temperatures for us. You can see those temperature scales are around 20. They drop down to about 8 or 9 degrees at night. And then in the January, February, December, these are our summer months. You can see the temperatures here. So keeping that in mind as we go forward would be useful. Okay. So here's the building we're looking at. It's an old 1933 building. It's what we call a semi. So two buildings are attached, and then they have neighboring buildings. So it's in a suburb. And here's an aerial. You can see here the building that we are interested in looking at is this half of the building, and this other half is somebody else's. And you can see it's a long and narrow plot, right? And this is what the back used to look like. So if you were looking here on this view, you can see that it was an addition made in the 1970s, which is not built very well. The original brick house probably will last for another 30 years, but another 100 years maybe. But this part was beginning to look its age. So the first thing that was done was there was a design that was commissioned, and the design was done by an architect, Peter Hewitt. And I will come back to areas of the design as we go through, but just to remember that this south elevation is what we are seeing here, okay? So that's a big window, sliding door window here. This is an east elevation, that's the west elevation. So this yellow bit is the bit that was knocked down and then rebuilt. Okay. So here's a design builder model. Okay. Now this was done a few years ago, 2016, 2017. The part that we're interested in is this part of the house, and the addition that we're looking at is really this part here. And if you look at this, the model, you can see that living zone has got all these parts to it. So floors, ceiling, walls, partitions. And on this particular wall, there are two windows. And it's actually these two windows here we're talking about. And this purple device, that's actually a shading structure. So everything in Design Builder which you use as a shading structure, we see that in a different color. Okay. Now we are using an expert view. So you have the model on the left side, the visual representation of the model in the middle, and then all inputs are available to you on the right hand side. All the analysis tabs are available to you on the top. Now, initially, when we start using it, we won't be using it in the expert view. So then things change around a bit. What happens is you get tips on the right side, and you have inputs on the top. So these tabs will come on the top. And on the bottom, you have all the analysis tabs will come down here. Okay, I'll show you that in a few minutes. So that's the structure of Design Builder as such. And you can see here I've modeled the neighboring building, and I've modeled the neighboring building on the other side as well. Okay. So the part that we are really interested in simulating and testing performance is that extension that has been demolished and redone. So first, daylighting simulation was carried out. And as you can see here, this is a illuminance map. So it's done under a particular sky condition called the CI overcast sky. So it's one point in time that you're calculating the daylight in. And if you look at these parts, you can see the new part that's being remodeled has got much more daylight than some of the older parts of the building. This kitchen area, you can see very clearly. One side has got a window, so the daylight levels are pretty useful. But this part of the kitchen is dark. And so by just looking at that, you can take a design decision. And the design decision might be to put a skylight. So here's a post-construction picture with the skylight that's put just over there. And that obviously changes the way the building looks. You don't have to put any lights on anytime the sun is available. Now this is a one point in time calculation, but on daylight analysis, we can also do annual simulations for daylight. And in India, in the ECBC, you will see something called a UDI calculation, which looks at useful daylight. So what it does is that you put a minimum and a maximum level. In this case, 100 lux is the minimum, 3000 lux is the maximum. And then the program cycles through and calculates what percentage of daylight hours have got daylight in this useful range. So if you look at these green areas, you can see that 60 to 66% of the time is useful daylight. And these are just behind the windows here. But in between the windows, you actually have very high useful daylight because you're not getting excess daylight. That's why you can see here 83, 85% of the time this area has got useful daylight. And these bedrooms, which were shown to have fairly low levels of light at that one instant in time, if you look at it across the year, you can see that the useful daylight is actually much deeper into that space. So it gives you a much different view. And this is all possible in Design Builder using the Radiance engine. You can do visual representation of sun performance, shadows, sun penetration. So this is a winter morning. Again, if you remember, month of May, June, July, August is winter for us. And that would be, in India, it would be December, January, November, October. But here I've put it for May the 21st, 9:30 in the morning. You can see the sun here. It's going in through these east-facing windows, high-level windows. You can see the sun patch on the ground there, shadows from the other buildings, shadow from this building falling on the wall. If, to give some confidence, I'll show you a post-construction picture taken on May the 23rd, so 2 days away from this. And that's what it looks like. And if you see this sun patch here, you can see how closely it matches with the model. So it gives you a good confidence that your model, if it's done correctly, gives you a really good indication of what is possible in real life. Okay, so here's another picture. This is the construction detail that went into that building. So from the outside, we have a WeatherTex wall. Okay, then there's a little air gap. Then there's some insulation with some wooden stud framing and some plasterboard on the inside. Now I realize that this is probably very different construction from India, but I wanted to point out that there are 4 layers. So the outside WeatherTex, which is a manufactured wood, air gap, insulation, plasterboard. You can represent that in design. So I've got 4 layers here for the wall. There's the weatherboard, air gap, insulation, gypsum, or internal plasterboard. Now, interestingly, if you notice, in this insulation layer, I have used this thing called bridging. Okay, so the bridging material is wood. If you go back and look at the construction drawing, you can see here a wooden frame, which is about 15% of that insulation layer. That is what I have put over here. So you can account for the loss of insulation because of thermal bridging by other materials. So each of these materials comes with all the data behind it. So in this case, this is the weatherboard wall, and you can see here thermal properties are there, vapor properties are there, surface properties are there, daylighting properties are there. So these are all built in, right? And if you happen to have a material that is not already programmed to Design Builder, I suspect you might find that quite difficult to get because we have everything in there. Then you can create your own. Okay, so it will then calculate for you what is the total U value or total R value of this construction without bridging and with bridging. So you can see these are things that are built into the program. Okay, and this is a little visual representation, so you can see that the way you've represented it is correct. So from outside, weatherboard, air gap, insulation, plasterboard. Okay. So here's a energy simulation run, or rather it's not an energy simulation run, but it's a temperature simulation run, because in this case, I have no heating and cooling switched on. I've closed all the windows. That's why it says windows closed. I have not got any blinds on the windows, but it's looking at the temperatures on the outside. This is the climate file, the green line is there. It's in the month of July, so this is just for 31 days of July. And you can see the coldest it gets to is about 1 or 2 degrees centigrade in winter. And the takeaway message for me is that without any heating and cooling, when the temperature is that low, the room itself is about 12 degrees centigrade. And I've actually plotted both the mean air temperature and the mean radiant temperature. And in this case, you can see the two are quite close together, which indicates it's a good design. Okay, and we can talk about those things later. Of course, the graph itself has some value, but really you want to understand the numbers. You can put them into Excel sheets, and because this is a living, I'm interested what happens in the daytime. So from 8 o'clock in the morning to 10 o'clock at night, and then I worked out what I call comfort. So from 19 degrees centigrade to 26 degrees centigrade, how many hours in July, total number of hours between 8 and 10 p.m. in July is 434. Of that, about half the hours are comfortable, which means the other half are uncomfortable. So I need to have a little bit of heating to compensate for that. So that's the kind of design decision that you want to try and get using simulation. So that was winter. Now, if you look at summer, you can see that now the sun positions changed quite a lot. The sun is high in the sky. This is an afternoon shot, so it's 3 p.m. in the afternoon, 21st of December. Again, as I said, the southern hemisphere, December is our summer month. You can see here that the sun is now coming directly into the space. Those two sunlight patches are there. And the impact of that is demonstrated in these two runs, the results of which I've combined. Okay, so on the bottom graph there's temperature, on the top graph there's sunshine, and that sunshine is really what's coming through these two windows which are facing west. Okay, so if you look over here, the green line is actually outside temperature in Sydney, and Sydney is a very moderate climate, so we rarely go about 30 degrees most days. You can see this one day is 34 degrees. It's really very, very lovely weather for most of the year. But what you can see is that even though the outside temperature is quite moderate, because there is sunshine coming through the west-facing windows, and this is day 1, 2, 3, 4, 5, 6, 7, and you can see just after noon, you can see huge amounts of sunshine coming through those west-facing windows. You can see the radiant temperature in the space is quite uncomfortable. Even when the outside is 25 degrees, you can get to very high temperatures in the space because of this sunshine. So the design decision might be to have some external blinds which stop the solar radiation coming through these west-facing windows. And when you do that, you can see that you immediately get a benefit. That radiant temperature is dropped from 40 degrees to about 32 degrees. So that's a benefit of 8 degrees centigrade. Now, there's no heating and cooling on this run, okay? So, you know, with that, I can then look at the temperatures the same way as before, and I can take a decision that if I put some external venetian blinds, which I can control, so these are motorized venetian shades, then I may not need any additional conditioning in the house. So the decision was taken to not have any air conditioning. Okay, so let me come back to this design. So this is the south-facing window. These were those east-facing windows next to the neighbor, because I didn't want to see what the neighbors, what was happening in the neighbor's house. These are those west-facing windows. Okay. Now those west-facing windows have got openable areas. You can open 2/3 of those windows, and that becomes useful when we look at natural ventilation. So Energy Plus is one of the few softwares which integrates the calculation of thermal heat balance as well as mass balance, so airflow networks which work out natural ventilation. Now that's different from CFD. Okay, this every hour you can understand how air is flowing because you have left some windows open, and therefore you can understand how natural ventilation works. Now I'm showing this particular hour for a reason. This is January the 29th at 4 o'clock in the afternoon. Because unlike how you may draw an arrow, the air is not coming in from the lower windows and exiting from the higher windows. Because of the wind direction and the wind speed, air is coming in from the top windows and leaving from the bottom windows and the big sliding door window on the south face. Okay, so that's something to understand. When we do natural ventilation, you might get surprising results, and that really depends on physics, and you need to understand your physics for that. Here's another January the 30th, 4 o'clock in the afternoon. Now, because of the the way the wind direction is and the wind speed is, you can see it's a bit more like what you might expect. Air comes in from here, the exits from these two windows, and you can see how that works. So we can do the same thing as we did for winter. You can put it into a spreadsheet. You can look at air temperatures, and looking at air temperatures, I can say that only about 6% of the hours is it uncomfortable. So yeah, it's possible to manage without it. But in this case, if I looked at the radiant temperature and did the same calculation, you can see that there are many more hours that might be uncomfortable. So that helps you make some decisions on design. Should you or should you not have any form of conditioning? Okay. Now, within Design Builder, there is a CFD engine, so you can take an hour and then get it to model what the temperature distribution is within the space. You can't do that in the natural ventilation options I showed you before. That does a bulk airflow every hour. This is for that 1 hour. It's telling me how the air is moving, and you can see here there's velocity, and the background fill color is temperature. So the temperature range is around 25 to about 26 or 27 degrees. The air speeds are about 0.5 meter per second to about 0.75 meters per second. And of course, there are many areas where the airspeed is very low. Okay, and you can do that as a vertical slice or a horizontal slice, but you can only do that for a selected hour. And the way you do that is you first run the energy simulation. In Energy Plus, it creates the boundary conditions, which you can then import into the CFD engine, and it's all seamless within Design Builder, and you can make those runs. Okay, so that's the final outcome, just to give you an idea. So there's a ceiling fan there. These are the east-facing windows. You can't see them, of course, and the west-facing windows over here, but there's the big sliding door that they're using for natural ventilation. Okay, so you'll notice I haven't spoken about energy so far. So I'm going to show you another building that we had worked on. This is a 2-story family home that we looked at. And in this case, we were much more interested in what was going to happen in winter. Okay, but another feature that Design Builder has is that you can do quality assurance by looking at things in a visualized way, where the colors will tell you what it is that you have applied. So you can see this partition is in this color, okay? And the pitched roof is in this orange color. And I have 2 different kinds of window glazing. So there's one color for the ground floor glazing and another one for the first floor glazing. And the reason is so that there are different performance of windows. So those are easy for you to check. Okay. So here I've taken a section through so you can see what's going on the inside. Again, you can do that within Design Builder. Okay. So here I've modeled what is the heating energy required to keep this building, the whole house, comfortable. Now, construction in Australia is not very tight. There's a lot of leakage that happens. So here we had a number, 15 air changes per hour when measured at 50 pascals. This is an international standard. You can look up something like Passive House, and they will tell you what their measurement standards are. So at 15 air changes per hour, the heating energy used across the year varies like that. This is the winter months. You can see here, I'm using about 20 kilowatts of thermal heating energy for this 4-bedroom, 2-story house. But if I then decide to actually make the construction tighter, so that instead of 15 air changes per hour, I only leak at about 3 air changes per hour, you can see how that energy use drops. If I then add a mechanical ventilation system with a heat exchanger, so I bring in air from outside, I exchange the heat with it, supply it to the living spaces, exhaust it from the toilets and the kitchen, you can see that all of a sudden I have dropped the heating energy even more. So from there in the beginning till down here. And if I put that into a spreadsheet, I can say that I can reduce 3/4 of the heating energy required, and I can reduce the size of the heating system by half. Okay, so these are interesting things that you can work out by doing this sort of simulation. So I'm going to leave it over there, and what I might do is very quickly go through another presentation, but in this case for a commercial building. Okay, so in this case, the commercial building it's a very standard building, but very old building. And it was in a place called Wollongong, which is about 120 kilometers from Sydney, down south on the coast. It was about 10,000 square meters, so about 100,000 square feet in Indian terms. It was tenanted by lots of government agencies, and this neighbor scheme is something that's unique to Australia. It's based on the actual energy bills. And 2.5 stars is a very poor performance. Okay, so the building was very old. It was 25 years old when we went there. There was a team of people working on the project. So the first thing we did was to create a model, and we made some very good engineering assumptions on how the model should be made and analyzed. And then using that, we also checked what the climate was like. And you can see here, this is the climate that's plotted for the whole year. Now, those amongst you who have some building science background or mechanical engineering background will recognize this is a psychrometric chart. And what it's telling me is that temperatures are on the x-axis here, and humidity is on the y-axis there. Okay. Now, typically when you're air conditioning a space, you're looking for somewhere between 8 and 10 grams of moisture per kilogram of dry air. And what this tells me is that fully half of the points are above this. So this is a really humid place. It's not very hot. You can see here temperatures rarely go above 30 degrees centigrade, but it's very humid. So this would be like a lot of South India would be, or Bombay would be, extremely humid. So your air conditioning system, while it may not have to do too much cooling duty, it would have to do a lot of dehumidification duty. So that's when you need to use your design skills. And so in this case, we came up with a innovative air conditioning system where the outside air was dehumidified before we put it into the building. So, and then of course you can size your plant, select the plant. In this case, we use small screw chillers that were quite efficient. And we created air handling units with that double coil. So the double coil is over here. But all of that was informed by the simulations that we did using Design Builder. And the end use was, or the output from that was, we made a huge energy saving. And in fact, some of the people didn't believe the amount of energy saving we managed to do, but it was off the meter. So, they couldn't actually say no to it. This was before 12 months, and this was after 12 months. And not only did we save energy, we also saved on demand. So the peak demand dropped from about 420 kVA right down, this case, to about 275 kVA. So you can see here energy use and demand savings for the months of November and December before and after the upgrade. So if you use these tools well, you can get some enormous benefits. And this was then certified from 2.5 stars to 5 stars based on the bills that we were able to show. And of course, in Australia, there's a lot of focus on how much did you spend, how much did you make. So in this case, there was an estimate of an uplift of $4 million in price of the asset, which they did sell, by the way, so they realized that profit. And it was because of all these things. I won't spend time on that, but just to give you an idea of how the modeling works. So at this point, I'll probably stop for a brief Q&A, and then we can quickly have a look at a design builder model. So if anybody wants to have any questions and answers, this is probably a good time to do that, and then we can have a quick look at design builder itself.
Thank you very much, Thomas. It was for the overview on the design builder, and you had a very interesting results on both the residential and also the commercial projects. So I myself have a question, if I can go ahead.
Sure.
So the residential project, like both the cases, it is post evaluation, and then you did simulation. So there was a process of calibration before even seeing what you can change, optimization of daylight or energy savings. So how I would like to know about the calibration process in design builder, like how close could you match and what is that you follow?
Okay, so in residential, we have got some digital thermometers in the spaces. So we have noted that the spaces actually stay within the ranges that we had predicted. So that was all we were interested in. In the commercial part, we were aiming for a 5-star neighbors target. And then because of that, you know how much energy use budget you have available. Because for that building of 10,000 square meters in that location in Wollongong, can work out how many kilowatt hours you have as a budget to achieve the 5-star rating. So we didn't need to go to any further calibration requirements. As long as we met the total energy use was within the range that was modeled, we were happy with that. We have done other projects where we have actually calibrated or modeled what the chiller energy use should be, modeled what the fan energy use should be, modeled what the cooling tower energy use should be, and then monitored that and then compared against that. And if you do a well-calibrated practical simulation, and that's hard because many people who do simulation need not understand how air conditioning systems perform and how they can be operated, what are the limits of practical operation. If you can do that, you can come pretty close. If you get within 10 or 15 or 20%, you're doing very well. Typically, there are people who get 50% discrepancy between what they've modeled and what the metered outcomes are. But we've typically managed to keep it within 20%.
Yeah, thank you for that. So if anyone has any questions, you can post it in the chat box or raise your hand if you want to talk to, so like we can unmute you.
So because we don't have any questions, let me quickly just show you what a design builder model looks like. And then we can have maybe some questions on that. So I can see there's a question in the chat. I'll just wait till I finish that and then we'll finish this and we'll address that. So here's a model, and in fact, we'll, in the coursework, we'll use a model very similar to this model here. So the way it works in design, and this is on learning mode. So you can see here it keeps telling you tip sheets on what you can do next. I'm going to go to this edit view, and over here you can see that I've got 3 floors, and the dark gray is all the opaque parts of the building, the light gray is all the window part, this purple pink purple thing is all the shading part, and in this case there's a awning that is all the way across here. You can see here that we have got ground floor, first floor, second floor. You can go to any one of these floors and have a look inside it, and you can adjust the way you look at it. So for example, if I put it in floor plan, you can see I've got a number of zones. Okay, and what I've done here is that those who are in the air conditioning industry will understand this probably. This is a real physical partition, so it is made out of some opaque material. These partitions are actually non-existent. They are virtual or imaginary partitions, but they are used to do sizing of air conditioning systems, working out what the temperatures and comfort, etc., are in each of these areas close to the perimeter. Okay, and the way to maybe show that to you is if I put it into this visualization mode. If you remember, we talked about the QA checking. So, in this part also you can see that the glazing that is above the shading, we put a different performance kind of glazing. And then this is a different glazing, which you can see here. But if I looked at it in a render view, where I can see the solar, the sun part, etc., and if I decide to take a section through it, let me take a section from the top, say. Okay. You can see that only that physical partition is shown. The other partitions which are not real, they don't show up in the visualization view. Okay. And if I say change that time, maybe if I changed it to say 2 o'clock in the afternoon, and I think I've got this on Bangalore's data. So you can see here that the patch of sunshine is happening along this edge, along the perimeter. Okay. And if I went, say, to the ground floor, where I've got the shading device, I may actually not have that patch. So here you can see the patch has sort of disappeared, and you can look at it here as well. If I take that same section again, let me take a section across this side. So yeah, so while there are sun patches on those 2 floors, because of that shading, you can see that's missing. Okay. Now, you can do energy simulation. So in this case, if I use what's called an ideal system, I can work out what is the thermal energy required to keep temperatures within a certain range. I can also model complex air conditioning systems. I think I have on this model, I have modeled a VRF system. And the way I've modeled the VRF system on this one is that there are 3 condensers, outdoor condensers. Each condenser is connected to a series of zones. And each zone group, so all the second floor zones are connected, all the conditioned second floor zones are connected to one condenser, the VRF system O2, and so on. And you can, of course, mix it up any way you like. So you can do all of that. You can work out the energy simulation. Then it will tell you what is the energy used by the compressors, by these fans, etc. Lighting, any equipment usage you may put in. So all of those things you can work out. Okay. Now you can do very complicated air conditioning systems. So you can do full VAV, 3 chillers, 2 cooling towers, and so on. Let me open a file which has a complicated solar system. I have got one where the geometry is much simpler, but the system itself is quite complex. Let me just find that for you. And while I'm doing that, it will take just a few minutes to open up because it's a fairly big model. Let me see if it works. Okay. Let me address there was some question in the chat. Okay, what are the topics that will be covered? So we will cover inputs into the model. How do you make a model? How's the geometry of a model made? Okay, and then we will do energy simulation, we will do daylighting, we'll do a little bit of natural ventilation, we'll do a simple air conditioning system. All of these things we will cover in the course. Now, there's a couple of things that you can do before you come to the course. For example, I'll put some links here on the chat and you guys can pick it up. For example, if you want to just have an idea of what Design Builder does, there's a short video on that. Let me put the description there as well. I'll give you this here. So that'll give you an idea on, you know, a little bit about Design Builder. A more comprehensive video, if you want to, it's a bit longer, about 15 minutes. You can have a look at this one. Okay, these are both videos you can look at to see how it works. Now, the residential example that I showed you, there's a more comprehensive lecture that I gave in a series on digital computing last year at one of the universities. You can find that link over there. And what I really encourage you to do is, before you come for the first class, there is one lecture that I give to all students who want to learn energy simulation, which really says, what is energy simulation? And that'll give you an idea of what all we cover during the course. We have modules, about 2 per day. So your Thursday and Friday, you do 4 modules. We'll work on one model. I'll show you how to do it so you guys can follow along. You'll have a, we'll give you a license, a temporary license for a month. And you can test out all of the features of Design Builder in that part, in that time. So I just wanted to show you, let me just see here. I wanted to show you a detailed, here we go. So in this model, the air conditioning system is being modeled in quite a lot of detail. If you see here, so there are a bunch of loops. So we have a chilled water loop. And in the chilled water, we have a supply side. So there are 3 chillers, 1 low load chiller, 2 main chillers. Each one has got a pump. There's a supply header, there's a return header, there's a controller, okay? And each of those things you can look at. And then that supplies chilled water to all the cooling coils in all the air handlers. And if you look at the air handlers, I've got one for each orientation. And that air handler, you can configure however you like. So in this point, I've got a cooling coil, a heating coil, a fan. I can add rotary heat exchangers. I can add a return air fan. I can add dehumidifiers, humidifiers. I can add evaporative cooling cell decks. All of those things can be done quite easily. And then each of the air handlers is connected to a series of zones. So if I pick one of the zones, this is north. So all the north zones will be connected to that AHU. And within the zone, we have a VAV box. In Australia, in the VAV boxes, which are near the perimeters, we add a reheat coil. And there's a return air diffuser there. So and you can do many, pretty much any sort of air conditioning system that you think of, you can do it there. So I'll stop it here. If you have questions, I'm happy to. Thank you for that issue. I think you've covered all the topics very well. Thanks.
Yeah. So if anyone has any questions, it's time now that you can post it. There's a question, sir. Is your software have any certified by any professional society in the UK?
Okay, so there are two questions. One is about certification and one is about CFD. Okay, so certification is easy to understand. Energy Plus, which is the engine that does all the calculations, that is always released after it goes through the ASHRAE specification for accuracy in building simulations. Okay, and if you look it up, both on the Design Builder website and on the Energy Plus website, it will tell you that. Okay, in UK, they have certified it for their certification requirements. We don't really, in India, you wouldn't really need that. In India, you might need it for ECBC or DEED or GRIHA. What's the other one? Forgotten now. But all of those you can do using Design Builder, which has got Energy Plus and Radiance for daylighting. Now there's a question on CFD. In this basic course, we won't be able to address CFD. There's not enough time to do that. IGBC, thank you, Manjivi. But hopefully we can get you up to speed so that you will know where to find the resources to do that. All the help files are available online. You can just Google Design Builder daylighting, Design Builder CFD, you'll find it. And we'll give you other sources which will allow you to progress from where we take you for this initial basic course. Yeah, in terms of the fee for the course, we'll put you in touch with the person, not the course, the software, sorry. We'll put you in touch with the representative for Design Builder software in India. There's Mr. Ahmed. He can answer your questions on the pricing. Okay. And it's very variable depending on whether you want just the architecture package or you want the HVAC package with it or you want the CFD package as well. So there are combinations of that. So it's not a very simple question to answer directly. But what I can tell you is probably that maybe the basic modules might cost you in the region of 1,500 USD per year for a commercial project. for a commercial license. Design Builder is very well recognized all around the world. In fact, it is now considered to be the most mature software for as an Energy Plus graphical user interface. Energy Plus is the gold standard for energy simulation software around the world. If you open up any CIBC magazine, ASHRAE magazine, or ASHRAE transactions, or CIBC transactions, then you will find that there are many papers available on Energy Plus, and people are using Design Builder very extensively for these things.
At this point, I would also like to announce to the participants that along with the course, there will be a 30-day free trial of the Design Builder software that will be given to the participants. And also about the course fee, there is a discount for the students. You can contact the GT Academy itself on the fee structure.
If you are planning to work in this field, if you are planning to work on any one of these rating systems, or you're interested in energy simulation or daylighting, this is a really good starting course for all of you. You probably won't find this level of interaction and detail available in any other coursework.
So the course is starting from 5th of May, and the scheduling is also announced as before. It will be for 3 weeks, 2 days in a week, that will be Thursday and Friday, 1 hour each. So the timings would be 5:30 to 6:30 in the evening. And the 11 modules will be covered, which has been posted above. There will be 2 topics on each day that will be taken up. So it will be live sessions or combination of recorded sessions also.
Yeah, I think it may be actually a little bit more than 1 hour. Hopefully each session will be about half an hour of tutorial and maybe 5 or 10 minutes of question and answer. And the idea will be that you can watch and follow along, and then you can, through the rest of the week, you can work on those 4 aspects that are being taught to you. When you come back, we'll do another 4 aspects to do that. So by the time you finish, you'll have a good grounding on all the main things that need to be, that make up an energy simulation model. That last link that I gave you on chat, please do go watch that lecture. If you don't watch any of the others, that's fine. But that one is, I would say, super critical, because if you can follow from there, then you know what we are going into and are going to deal with all those aspects that are in that lecture.
So let's come to end of the session. I think if you have any further queries, you can always contact GT Academy. You can visit the website and contact us via email or telephone. And the course is open for registration. There's a question on certifications.
That one I might let Mr. Dhruv answer if he's there.
Yeah, I'm there. PC, thank you. So there's a question on certifications after completing this course, such as Certified Energy Manager. So if you're talking about the Energy Manager or the Energy Auditor certification, which is given out by the Bureau of Energy Efficiency, so there are two agencies. One is in India, the other is Association of Energy Engineers, AEE. So when we look at certifications around energy auditing or energy management, they typically deal with a certain additional aspects, different aspects around energy audit management and all that. So this certification, this course probably is more around how you build models, how you analyze performances. Whereas I would say, because I am a certified energy auditor myself, so those kind of certifications require a different knowledge and a different level of understanding about the industry as a whole. So we're not just talking about buildings when you look at certifications like CE and CEM, but you have to look at the entire industry, including the manufacturing industry, the power plant industry, and so on. So I would say that's a different line and requires probably a lot of additional aspects of learning before you will be able to qualify for these kind of certifications. I hope that answers your question. Great. So there's another question that I see. Yashaswini, if you would like to take.
Yeah, so is it possible to post details to us by email? So I would say you can write to us anytime, so we'll revert back, or else I'm just giving you the link for the courses. You can go through the details of all the courses that's there by the academy, including this course itself. And the course fee would be 12,000 plus GST.
Yeah, just to add in, so for all the people who've joined the session today, we will be sending out the details over email as well.
Okay. Yes, 12,000 plus GST. Thank you everyone for joining today's session, and thank you, PC Thomas. It was a very interactive, as well as the results were very interesting for us to see. And I hope the participants take up the course and take the benefits of the trending software that's in a lot of demand in the market today. And as you all know, that simulation is a very important tool for going into the green building certifications also. So thank you everyone for joining today.
Thank you, everyone.
Thank you, and hopefully we'll see you on the course. Bye now.